Okay, the third set, this is a little tricky. If you get it in the first 5-6 minutes, the remaining will be smooth sailing. Otherwise, you might end up wasting a lot of time in this. So let's go ahead and take a look at this set. So some men were tasked with completing the construction of a building during COVID-19 lockdown. Only 2 men worked on each day of the month of June. So June has 30 days. Please keep in mind. The men worked in pairs such that each of them worked for the same number of days. Thus, it took the entire month of June to finish the work. All possible pairs of men worked and each pair worked for an equal number of days. First of all, we don't know how many pairs are there, which means we don't know how many men are there. So if there are n men, so NC2 will be the number of pairs. This will be the number of pairs, and each pair, if they work for X number of days. So NC2 number of pairs, each pair working for X number of times. This should be adding up to 30. Right? Because the total number of days are 30 and every pair works for the same number of times. Right? All possible pairs work, each pair work for an equal number of days. So each pair work for X number of days. Now the question going forward will be, so if you look at it, the amount of work done by pairs of men on any of the days were 80, 116, 104, 122, 140 and X units. We don't know what is the value of X. So there are totally 6 values given to us. So NC2 pairs should be equal to 6. What is the value of N? Clearly we can see that N should be equal to 4 because 4C2 only is 6. So we have 4 people working for us. So 4C2, and how many times will they work in a month? The total should be equal to 30. So this is 6 pairs into X should be equal to 30, or your X is 5. So every pair is working for 5 days. Every pair is working for 5 days, like that 6 pairs working for totally 30 days. Now keep this aside. Let us say the people are A, B, C and D. Efficiency of A is greater than B, B is greater than C, C is greater than D. Let's take it like this. These are the 4 people. It is observed that the units of work done per day by each one of the men was a different prime number. So clearly all of them are distinct and they are prime numbers. So now let me write down the numbers, these totals, the amount of work done in descending order. So 140, then I have 122, then I have 116, 104, 80. Now the question is where to place X. So I will break this X in 3 possible ways. So case number 1 is X is at the top. This is case number 1. Case number 2, X is at the bottom. And case number 3, X is anywhere in between. X is anywhere in between. Now, clearly, always, if I take AB, so what are the combinations when I have these 4 people? I have A and B combination, A and C, A and D, then B and C, B and D, and then finally I have C and D. So totally I will have 6 combinations. So these 6 will be these 5 plus the value of X, depending upon where the X is. So if I add all of them, what do I get? If I add AB plus AC plus AD plus BC plus BD plus DC, totally I'll get 6 of them, which means I can take 3 common. I'll get A plus B plus C plus D. Now what have I done here? This is A plus B, work done by A plus B. This is work done by A plus C on one day, work done by A plus D on the other day, and so on and so forth. B plus C, B plus D, and then D plus C. So this will give me 3 times of A plus B plus C plus D should be equal to sum of all of them plus X. So if you add all of them, you'll get 6, 10, 12, 2, 1, 8, 9, 10, 14, 16, 6, 1, 562 plus X. Right? Now what should be the value of X now? A plus B plus C plus D. Now let's start with case number 1. Now in case number 1, you are saying that highest value is X, which means A plus B should be equal to X. And the least value is C plus D, that is 80 in the case number 1. This is case number 1. Case number 2. Case number 2, 3 times of. Now case number 2, X is at the bottom, which means C plus D is X. C plus D, A plus B plus C plus D. So A plus B is 140 and C plus D is X. Okay. And this is again equal to 562 plus X. And case number 3. Case number 3, 3 times of A plus B plus C plus D. Now if X is in between, it means it is not above 140, it is not below 80. It is in between 140 and 80, which means the topmost should be 140 and the bottommost should be 80. So this should be equal to 562 plus x. So these are the three cases. So let's take case number 1. Case number 1, what do I get? I get 3 times of x plus 80 is equal to 562 plus x. And this gives me 3x plus 240 equal to 562 plus x, or 2x equal to 322, or x equal to 161. Now if x is 161, please keep in mind x is the sum of two people, and these are prime numbers. Both of them are prime numbers. So 2 prime numbers is giving you 161. 161 is an odd number. So 2 prime numbers is giving you 161. Only explanation is one of them has to be 2. The other one has to be 159. There is no way in which you can get 161 otherwise, because even plus odd only can give you a final odd number. Now 161 in case number 1 has to be the highest, and we took a plus b as x in the case number 1, and we are getting one of them as 159, the other one as 2. But remember, we always took a is greater than b and b is greater than c. So you cannot have 159 and 2 possibility at all, because if one of them is a, the other one b will become 2. So c and d will become greater than 2 then, because they are prime numbers. So other prime number, there's only one prime number 2, and all other prime numbers are greater than 2. I mean, 2 is, in fact 2 is the first prime number. So this case is not possible. So this is ruled out. Case number 1. If you look at case number 2, you will get 3 times of 140 plus x is equal to 562 plus x, and this gives you 0 to 420 plus x is 420 plus 3x is 562 plus x, and this gives you 2x equal to 142, or x will be equal to 71. Once again, x is sum of two people's work, prime plus prime. Again, 71 is an odd number. The only way in which this can happen is one of them is 2, the other one is 69. Clearly 69 is not a prime number. Anyway, 2 prime number is ruled out. So case number 2 is also not possible. Therefore, we will be left with only one case, and that case is 3 times of 220 is equal to 562 plus x. This gives you 660 minus 562 is equal to x. So how much is this? This is 660 minus 562. This is 8 and 9, 98. And you can clearly see 98 is an even number. It could clearly be the sum of two prime numbers. So this is the only valid case. So now let me clear everything and write down what we know. We know the numbers are 140, then 122, then 116, then 104, then we have a 98, and then we have a 80. Okay, so this is your a plus b. This should be your c plus d. The second highest always will be a plus c. The second lowest will always be b plus d. So please keep in mind, when you have a, b, c, d in this order, the highest will be always a plus b, and the second highest will always be a plus c. The least will be c plus d, and the second least will always be b plus d. Now in between these two can be, it could, so the remaining ones will be b plus c, and so we have a, b, a, c, a, d. A plus D. So B plus C and A plus D could be any one of them. There is no guarantee which one is going to be what. Okay. So let's start looking at the values. So if I take A plus B plus C plus D, in fact, you have these values. You can start looking at finding the individual values from equations over here. So where do we start from? So the way to look at this is start with 80. So we are looking at the possible values of 80. So 80 is equal to C plus D, where both of them are prime numbers. So let's start with 3. 3 and 77, not possible because 77 is not a prime number. Then 5 and 75, not possible because it's not a prime number. Then 7 and 73, may be possible. 11 and 69, not possible because 69 is not a prime number. 13 and 67. 67 may be possible because 67 is a prime number. 17 and 63, so may not be possible. 17 plus 63 not possible because 63 is not a prime number. Then 19 plus 61 may be possible. So two possibilities. Similarly, continue doing this. Next is 23 plus 57, not a prime number. 57 is not a prime number. 25, 27, 29. 29 plus 51. Not a prime number. 51 is not a prime number. Then 31 plus 49. 49 is not a prime number. 35, 37. 37 plus 43 may be possible. Then we have 39 is not a prime number. 40, 41 plus 39 not a prime number, and the remaining will be repetitive. So we have 4 possibilities. 1, 2. We have 2, 3, and 4 possibilities. So remember, C is greater than D. So in fact, this I'll write this as D and I'll write this as C. So the first column ones are D, the second one is C. So then we will use what is A plus C. A plus C is 122. So in this case, A plus C is 122. If C is 73, then your A will become 122 minus 73. This will be 9 and 11, 49. 49 is not a prime number, so this case is also gone. Next, once again here, A is equal to 122 minus C. C is 67, so 67. So this will be 5. The moment you see ending with a 5, this will not be a prime number because there is no number except 5 which can end with a 5 and still be a prime number. But anyway, if you look at it, this is 6, so this is 55. Okay, that's anyway not a prime number. Then if you look at the third possibility, A will be equal to 122 minus C. C is 61, so this will be 61. But again, remember, they are all different prime numbers, so A and C both cannot be 61, so this is gone, which means this should be working out. So A will be equal to 122 minus C. C is 43. So this will be 9 and 11. 11 minus 4, 79. So we get your A value as 79. B we will find out. C should be equal to, how much did you get? 43, and D should be equal to 37. So we have B plus D is equal to 98. D is already 37. So 98 minus 37 will be 61. So your B will be 61. These are the 4 values: 79, 61, 43, and 37. Okay, so let me write this down. A is equal to 79, B is equal to 61, C is equal to 43, and D equal to, I think that was 37. Now let's start looking at the question. If the man with the least efficiency, that is 37 units of work, never made it to work, then on which day of June would the construction of the same building be completed if the remaining men work together every day? First of all, we need to look at the quantity of work. Now, to look at the quantity of work, each person, remember, it is each person is working for how many days out of 30 days? There are 4C2 pairs, which is 6 pairs. Right? 6 pairs. So this is one cycle. Right? This is one cycle. And 6 into 5 cycles. So there are totally 5 cycles. So that is 30 days. So 5 cycles will continue. So in each cycle, each person will be working for 3 days. In each cycle, each person will be working for 3 days, because A will work with B, A will work with C, A will work with D. Similarly, B is working with A, B will work with C, and B will work with D. Similarly, C is working with A, here C is working with B, and C will work with D. And therefore D will work with A, D will work with B, D will work with C. So everybody in one cycle works for 3 days. So 3 times, and like that there are 15 cycles of A plus B plus C plus D. This is the total quantity of work. So the total quantity of work is 15 times of sum of all of them. What is the sum of all of them? 9 plus 1, 10, plus 1, 20. So 20, 3, 4, 5, 5 plus 4, 5 plus these two is 10, 15, 15 plus 7 is 22. So 220. This is the quantity of work. This quantity of work is now being done by the top 3 efficient people, because the least efficiency guy is not working at all. So we are looking at 79 plus 61, that is 80 plus 60, 140, 140 plus 43, 183. So this is 183 into number of days is D. So what will your value of D be? It will be a fraction, of course, because they are not looking at exactly what is the time. They are looking at which day. They're looking at which day of the week. So you have to divide it and get the answer. 15 into 220 divided by 183. So this gives you D is equal to 18 point something, which means this is the 19th day. So this is the 19th day. The first answer is 19. Right? Now the second question, if all the men but one work together, once again, A was 79, B is 61, C is 43, D is 37. If all the men but one work together every day starting from 1st June, then on which date the work cannot get over? So let's say we are starting with, so total work is 15 into 220. This, now we have to look at different possibilities. If case number 1, A is missing. If A is missing, then the other 3 will work for time T or days D, and the total of these 3 will be 40, 70, 80, 141. So the time when it is going to finish will be 15. So days when A is missing. When A is missing, it is 15 into 220 divided by 141, which means this is 23 point something. So this is 24th day. So 24th day is possible. We are talking about cannot get over, which means not possible. Let's move on to the second option, second case. If B is not working, which means the quantity of work is still 15 into 220, which is equal to D number of days into the calculation when B is not there. If B is not there, only these 3 should be added. So 43 plus 37 is once again 80. 80 plus 79 is 159. So this division will be by 159. So this will be D will be equal to 20 point something, which means 21st day the work will be done. So C is also not your answer. Next, look at what happens if C is missing out. If C is missing out 15 into 220, and the total should be without C. So 79 plus 61 is again 140. 140 plus 37 is 177 into D. So 177, if you take it out, it will be 18 point something, which means this is a 19th day. So this is also not your answer. Therefore, A has to be. But just to be sure, take a look at what happens when D does not work. If D does not work, in fact, we calculated this in the previous question itself. It will be 19th day the work will be getting completed. So 18th day. So even if the least person does not work, it will take 19 days to work. So you cannot finish the work in 18th June at all. Right? You cannot finish the work on 18th June at all. So that's your answer. Moving on to the next question. Question number 11. Starting from 1st June, for each day, each man works alone, one after the other in a repetition such that the man who starts doesn't work again until all the others have worked exactly once. So you are starting with A, then B, then C, then D. Let's say this is the cycle. This cycle continues till the work is completed. On which day will the work get over? Okay, so let's say that we are starting, the total work is 15 into 220. This is the quantity of work. This is equal to, now first cycle, if all of them are working together, so A is 73, this is 61, this is 30, this is 43 and 37. 73 and the first one, A was 79 and 61. So the total of all of them in one cycle, cycle 1, is 70, 71, 40, 140 plus 80, 220 into number of cycles n. Okay, so it's in first cycle it is 220, second cycle will be 220, third cycle will be 220. On which day will the work get over? So 220 into number of days, so then the day it will be 15 cycles. 15 cycles, but remember each cycle, because 22 and 22 gets cancelled, number of cycles are 15, but each cycle is 4 days. Each cycle is 4 days, so 15 cycles is totally 60 days. Totally 60 days. So you have 30 days of June and 30 days of July. On the 30th day of July, the work will get completed. So that is option D. Okay, right. Question number 12. If the men are paid 3,96,000 for completing the work, then how much extra payment does the man with the highest efficiency? So A is 79, B is 61, C is 43, D is 37. And now please keep in mind, all of them are working for equal number of days, 15 days, 15 days, 15 days and 15 days each. So when the time is constant, the division of work is simply based on the efficiency. So how much more will the man get? So basically, we are looking at 3,96,000 divided by total efficiency is 220, all 4 of them, into the difference between A and D. So 79 minus 37. So this is 2 and 4 into 42. Okay, so the answer will be, so 0 and 0 gets cancelled, 396,000 divided by 22 into 42. So this will be 75,600. That is your answer, because all the number of days are equal. So the division is purely in terms of the efficiency of each person, right? So question number 13, again not a difficult one, this is quite easy. So we have the efficiency of the people as 70, 79, 61, 43 and 37. So any two combination, two pairs should give us 40 by 49. So 40 by 49, if you look at it, this can also be expressed as 80 by 98. Is it possible for us to get sum of two numbers as 80 and the sum of the other two numbers as 98? Yes, definitely it's possible. You can see 43 plus 37, total is 80, right? And we can see 98. So how will you get 98? 70, 61 plus 37. Total will give you 98. So 80 by 98 is when? So when you have A, B, C, D. So if you take this as CD by BD, you will get the ratio that you want. So A is not your answer because you're looking at cannot be. Similarly, if you look at 49 by 58, so 49 by 58 can be written as 98 by doubling it. So 58 double is 116. We know 98 can be got. How can you get 116? Look at the numbers. Which two numbers total will give you 116? We can see that 116 can got by 79 plus 37. 79 plus 37 is 116. So therefore, B also you can get. So B is not your answer. If you look at 7 by 10, 7 by 10 can be written as, now remember the denominator is 10. So it means you are looking at numbers which are all ending with a 0. So only two possibilities, A plus B will end with a 0 or C plus D will end with a 0. So if the denominator is 80, then the numerator should be 7 8s are 56. But there is no two numbers adding up to 56. So 7 by 10, it is not 56 by 80. What else could be possible? If it is not 8, if it is not into 8, then it should be into 14 because 79 plus 61 is 140. So 140, because I'm writing it as into 14, which means 7 into 14. 7 into 14 will be how much? 70, 7 plus 28. So 98 by 140. Now 140 we know is possible by A and B. This is A plus B. And we already know 98 is possible. Okay, 98 is possible with 61 and 37, which is B and D. So D is also possible. So this is not your answer. Therefore, you can see that option C is not possible at all. 7:13. Right? So moving on to question number 14. When the men are arranged in the increasing order of their efficiency in your queue, what fraction of the work is done by the first two men? Is the work done by the other two men during the same time? So we have increasing order. Increasing order means 37, 43. Then we have 61 and 79. What fraction of the work done by the first two men? So these are the first two men. Is the work done by the other two men during the same time? If the time is constant, then the work done is a function of their efficiency. So this total is 79 by 61 plus, this is 80. 80 by 140. So this is 2 4s are 2 7s are 4 by 7, option A. This is a very, very simple question.